Hey everyone, today we're going to talk about servo motors and hopefully end with a lab called animation boards. So servo motors are regular motors. They spin, they have wires. They have two very unique features that make them, I think, amazing. One is that they're geared. They always come in these big black boxes full of gears. What that means is that instead of spinning fast, they usually spin very slowly but strongly. We call that torque. So you're not going to use a servo motor to make a fan, but you might use it to open a door or lift a gate on the back of a van. So that's very helpful for more precise control over projects. The other thing that makes them unique is that they can't spin 360 degrees like a regular motor. They could only spin from 0 to 180 degrees and then back again. But they don't have to spin the whole way. You could actually tell it which angle within that 180 degree range to swing to and back and forth. So you might use it to make windshield wipers or even a fuel gauge on a car and have it point at the percentage of fuel that's left in the tank. So they're very useful. One of the most common sensors we have in Innovation Day projects. Let's take a look at the circuitry. Any servo motor you have is going to have these three main wires: power, ground, and data. The power wire will almost always be red. The ground wire might be black or brown or some dark color. And the data wire will usually be some bright color like yellow or orange. But almost all servos are going to have those same three wires. A lot of sensors in general are going to be having those three wires because it's very common for a sensor to need power, ground, and data, which is why our Sage Arduino boards come with all the data pins aligned with 5 volts and ground pins. These red and blue pins cannot be controlled via code. They're dumb pins, as we would say. All they do is provide 5 volts and ground. And the reason we put one next to every single data pin is specifically for sensors like this that need 5 volts, ground, and data. So let's say I want my servo motor here and I want to connect it to pin 13. With one connector, I now have connected my servo motor to digital pin 13, 5 volts, and ground. All in one go. Let's see how it works. The servo code is really easy to use. You really only need 4 lines to get the servo moving. The first line is to include the servo library. That gives you more words to work with while using the servo. The next line is to name your servo. So servo space and then some sort of name in there. It's helpful to name the name something related to what you're using the servo for. So if you were making a robot arm, you might call one servo knuckle and one servo wrist and one servo thumb, things along those lines. In the void setup, there's only one line you need to add. It's arm. That's the name of my servo. My servo's named as arm. Dot attach, and then the pin that you're plugging that servo into. So I have one servo and I plugged it into pin 13 like we saw before. Then all you really need is one line of code to move the servo within the void loop. The name of your servo, so in this case it'll be arm.right, and then the number is the angle that you want the servo to go to. It's not how many degrees to go, it's the degree you want it to go to. So in this case I'm doing degree 0, it'll go all the way to the beginning. I'll add a delay. The delays are important in servo code because you need to give the servo time to get to the angle that you just asked it to go to. And then I will go to angle 150. And I'll delay again. I'm a copy and paste coder. So we have go to angle 0, wait 1 second, go to angle 150, wait 1 second, go back to the top of the void loop and continue that. Essentially, we'll have a windshield wiper. I'm going to add a little bit to the code now to make it do different lengths of wiping. So first I'll do a full wipe from 0 to 150, and then I'll go back to 0 and wipe maybe only 25 degrees. So I'll do a 0 to 150, and then a 0 to 25, and then back to the top of my void loop, 0 to 150, and then a 0 to 25. Power. Servos are motors, and the bigger they get, the bigger the motor inside is, and they use a lot of power. And when we use the 3-pin adapter that's built into the Arduino board, we're essentially using the 5 volts that's applied from your computer, and that's not really enough to power multiple servos. You could usually get away with one servo motor If you're using more than one servo motor at a time, the little blue ones might be okay. Anything else, probably not. There is a great video we made on powering servo motors. It's a whole separate issue you're going to have if you're trying to power multiple servos from the same Arduino. It's not difficult, just the wiring changes a little bit. The last thing that I want to talk about, and is often misunderstood by students, is angle orientation. A servo motor can go anywhere from 0 to 180 degrees, but you don't get to pick where that 0 and where that 180 are. It might be flat across and you're doing a full arc. It might be lopsided and you're actually going down and up in some weird angle. What happens when you want to adjust where that 0 to 180 range is within your servo? And you do that by removing and reapplying the wings. The wings are crucial. It's really hard to attach things to a servo motor if you lose the wings, so try and hold on to the wings. But the way you do that is you pull off the wings, reorient the wings, and then place them back on. We're going to now use the servo motors in something called animation boards, where we combine the servo motors and LED lights that we used in the traffic light and blink app to make some sort of mini art installation. You could use construction paper, felt, cardboard, whatever you have lying around, to try and make some sort of little motion art exhibit. The servo motors are really used throughout the course, throughout the labs. They're great for Innovation Day projects. Anytime you want something to move or be articulated, it's a really great product. Good luck, guys.